In this video, we're going to discuss the vertex, or the turning point, of quadratic functions. All quadratic functions have a turning point. That turning point will either be a minimum. When the graph opens upwards, the turning point will be a minimum. And when the graph opens downwards, the turning point will be a maximum. There are many different ways we can calculate the vertex, depending on different scenarios. Let's look at a few of them. If you're given a graph of your parabola, it's very easy to just count the boxes and see where the vertex is, where the turning point is. This graph in red has a minimum point at -5, -4. And that's very easy to see from this graph. Let's say you're not given a graph. Let's say you're just given an equation. Let's look at an example of that. Let's say you're given the equation y is equal to 2x squared plus 9x minus 5. The equation to find the vertex of a parabola is x is equal to -b over 2a. This will give you the x coordinate of the vertex. Then to find the y coordinate, you have to plug in that x coordinate that you found into the original equation. You might recognize the equation, x is equal to -b over 2a. That's the equation for the axis of symmetry. The axis of symmetry is straight down the middle of the parabola. The parabola is symmetric about this line. And you'll realize that in every parabola, the vertex is always going to be on the axis of symmetry. So we use the equation for the axis of symmetry to find the x coordinate of the vertex, and then we use that x coordinate, plug it into the original equation to solve for the y coordinate of the vertex. Let's try it using this equation, y is equal to 2x squared plus 9x minus 5. To find the x coordinate, we're going to do x is equal to -b, b in this case is +9, over 2 times a in this case is 2. So the x coordinate of the vertex is -9 over 2 times 2, which is 4. Now we have to plug in -9 over 4 into the original equation for x to solve for y. So y is equal to 2 times what we just found, -9 over 4 squared, plus 9 times -9 over 4 minus 5. Now the easiest way to do this would just be to punch the whole string into your calculator. So 2 times alpha y equals, enter to get a fraction, -9 over 4, close parentheses, squared, plus 9 times alpha y equals, enter to get a fraction, -9 over 4 minus 5. That is -121 over 8. So the y coordinate of this vertex would be -121 over 8. We can find that in a decimal to see approximately what it is. Math, down to decimal, and enter. So it would be approximately -15.1, or just do -15.125. And let's see if that's accurate. Let's graph the parabola. I'm going to graph it in y2 because I wrote in red. Y is equal to 2x squared plus 9x minus 5. We could graph this in zoom 6, but remember that we already solved for the y coordinate of the vertex we think is -15. We think our vertex is -9 over 4, comma, -121 over 8. We think that the y coordinate of our vertex is -15. So if we solve in zoom 6, our minimum y in zoom 6 is only -10, and we're not going to be able to see our vertex even. So we have to make the minimum y a little bit lower. Let's make it -20. So we go into window, go down to y min, and type in -20, and then graph. There we see our vertex. And is it possible, does it make sense for the vertex to be at -9 over 4? 9 over 4 is about -2.25. So that would be over here and going down, and negative 15.125 would be somewhere over here. So that looks about right for where the intersection of the two green lines looks about right for where the vertex should be. Let's look at another example. Let's find the vertex of y is equal to negative x squared plus 4x minus 4. To find the x-coordinate of the vertex, we're going to use x is equal to negative b over 2a. So x is equal to negative b in this case is 4 over 2 times a in this case is negative 1. So x is equal to negative 4 over 2 times negative 1 is negative 2. Negative 4 over negative 2 is positive 2. So the x-coordinate of the vertex is positive 2. We're going to plug in x is equal to 2 into the original equation to solve for y. So y is equal to negative 2 squared plus 4 times 2 minus 4. Y is equal to 2 times 2 is 4, and then we have to multiply by this negative 1. So we have negative 4 plus 4 times 2 is 8 minus 4. So y is equal to negative 4 plus 8 is positive 4. 4 minus 4 is 0. So y-coordinate of the vertex is 0. And our vertex is at 2, 0. Let's see if this is correct. Let's graph it on the calculator. I'll graph it in y2 because I wrote in red. Negative x squared. Sorry about that. X squared plus 4x minus 4. We'll graph it in zoom standard, zoom 6. And you could tell very easily that the turning point, the vertex of this parabola, is at 2, 0. There's also a way to have the calculator tell you what the vertex of a parabola is without you even solving it. Let's use the parabola that we just graphed, just because it's already on the screen, and let's have the calculator tell us where is the vertex of this parabola. You have to first decide on your own, is this vertex going to be a minimum or a maximum? When the leading coefficient is negative, then the parabola is going to open downwards, and you're going to have a maximum point, like we had in this red equation over here. If the leading coefficient is positive, like y is equal to x squared plus 5x minus 2, the leading coefficient is a positive, the parabola is going to open upwards, like this parabola, and the vertex is going to be a minimum. So we have to decide first if this is going to be a maximum or minimum. Obviously, we know this is going to be a maximum. We already graphed it. We already saw. But once you decide this parabola is going to have a maximum point, click on the second button. Whenever you click on the second button, if you see when it's not clicked, it's in blue. You're activating the little blue words above each button. So we want to go into this calc menu. So we're going to click the second button and then trace. Scroll down. We have to choose either minimum or maximum. So we already decided that we have a maximum, so we click maximum. Then they tell us to find the left bound. We want to go anywhere to the left of the maximum. So we're on the left of the maximum, click enter. Now they want right bound. Go anywhere to the right of the maximum. Somewhere over here is good enough. Click enter. Then the calculator wants us to guess. So just scroll over to the maximum and click enter. And the calculator calculated for us 1.9999979. We can round this, and on the Regent you should round this to 2, to x is equal to 2. And if you'll notice that y is equal to negative 4.6 e negative 12. Negative 4.6 e negative 12 means negative 4.6 with the decimal place moved 12 places to the left, which is so close to 0 that on the Regent we just assume that this is equal to 0. Maximum point of this graph is 2, 0, like we solved before. Sometimes the calculator will give you an exact answer, like 2, 0. Sometimes they won't, and you have to realize that 0.9999979 is close enough to 2 that on the Regent and everywhere you'll just round it up to 2. Let's look at one more example using the calculator. This time we'll do one with the minimum. Let's find the vertex of y is equal to x squared minus 13x plus 12. And we're going to do it on the calculator. First thing we need to do, we need to decide, is this going to have a minimum point or a maximum point? Since the leading coefficient is positive, the parabola is going to open upwards, and therefore it will have a minimum point. So we're going to go into y equals. I'm going to graph it in y2 because I wrote in red. X squared minus 13x plus 12. And then we could try zoom 6. We might need to adjust our window though. We don't see the minimum point here because the minimum is somewhere down over here. So we're going to adjust our window. We're going to make our y minimum a little bit lower, and then we're going to make our x maximum a little bit bigger so we could see into further down into the fourth quadrant. We're going to go to window, x max, let's make that 20, and y min, let's make that negative 25. And graph. We still don't see it. Let's go back to window. Let's make our y min a little bit lower. Let's make it negative 45 and graph. Now we see it. And we're going to use the calc menu to find the minimum. So we're going to press the second button, trace again to the calc menu, down to 3 for minimum, enter. We need to tell the calculator the left bound. So we're going to go to the left of the minimum point, click enter. We're going to go to the right of the minimum point and click enter. That's the right bound. And now for guess, we're going to go to where we think the minimum is, somewhere over here. Click enter. They tell us the minimum is 6.499992 and 30.25. So since we have 6.499999 whatever, it's safe to assume that what the calculator really means is 6.5. Since there are it's 0.99999, it's so many nines repeating, we can assume that it's really 6.5, comma 30.25. So in general, if you have, let's say, 6.000001, you could assume that this is 6. If you have 5.999999999 something, you could assume that this is 6. If you have negative 0.000001, you could assume that this is just 0. There's one more thing that we're going to discuss related to the vertex, and that is vertex form. Vertex form of a parabola is y is equal to x minus h squared plus k. In previous lessons, previous videos, we've only discussed standard form of a quadratic. Y is equal to ax squared plus bx plus c. Vertex form, y is equal to x minus h squared plus k, is just another way of writing a parabola. But in vertex form, you could tell very easily what the vertex is. Because in vertex form, the vertex of the parabola is always going to be h comma k. For example, the vertex would be h comma k. Let's look at an example. Let's say we have the equation y is equal to x minus 6 squared plus 3. The vertex of this parabola would be 6 comma 3. And we can graph this parabola to see if that's true. Let's go into y equals, and we'll do x minus 6 and square that, plus 3. Let's graph in zoom standard, zoom 6. And we'll have the calculator tell us the exact coordinates. We see that's a minimum value, so we're going to do second calc, down to 3 for minimum. Now the calculator wants us to tell it the left bound, so we're going to go all the way to the left, press enter, all the way to the right. Even though we didn't see for the left bound that the cursor was all the way on the left, we saw that the x values were already negative, so therefore we know we're definitely to the left. Now we're by the right, you can see the cursor, and we're going to guess, press enter. They tell us the minimum is 5.99993, comma 3. So as we discussed before, 5.9999999, you can just round that up to 6, and the calculator really means to write 6, 3, which is what we found, which is what the vertex of this parabola is. Let's look at another example in vertex form. Let's say we have an equation in y is equal to x minus 3 squared minus 5. The vertex of this parabola is h comma k. So h in this situation would be 3. And k, normally k has a plus sign before it. But in this equation, k has a negative sign. That really means that k is negative 5. Why is that? Because let's say we would rewrite our equation. Y is equal to x minus 3 squared minus k we're deciding is going to be negative 5 this time. Negative 5. And then if we simplify that, y is equal to x minus 3 squared plus 5. Now we get back to our original plus k. So we have to switch the sign and make this a negative 5. Let's look at one last example. Let's say we have y is equal to x plus 3 squared plus 5. So in this case, it's very easy to tell what the k is because it's just 5. Normally we have minus h. In this situation, we have a plus 3. So let's say we would rewrite our equation, replacing the plus 3 with a minus 3. Y is equal to x minus 3 squared plus 5. Now this equation resembles what it's supposed to. So what really is happening here, h is really negative 3, and the coordinate of the vertex is negative 3, 5. So just in summary, your equation should always be in the form y is equal to x minus h squared plus k. If instead of having minus h, you have a plus h, you have to switch the sign. When you're rewriting your coordinates, you have to switch the sign. If instead of having a plus k, you have a minus k, you have to switch the sign of the k.